Pretty simple to do the mates, right? You get lots of common corners and parallel faces and such. But the first thing I want you to do is go up here to Office Products and click on SolidWorks Simulation. Because that will generate a new tab up here. See how you got 5 tabs right now? SolidWorks Simulation should add me a new tab. Okay, I'll accept that. Now, completely reading it only because I read it earlier. And now I can identify that I want to do a new study. I want it to be thermal study. Yes, I want it to be a thermal study. Now I can do things like see some thermal loads and stuff up there. And that's important, right? There's a few things that you want to do here. I'm only going to kind of hit the high-level stuff. What I'm trying to do is reduce the AI demand for those who are kind of coming in here. I know some people were taking a picture of the screen here. I'll show you the next set of steps, and I'll try to walk you through them quickly, because I know not everybody in here is doing this. I think I got here on the first set of stuff. Now we're in here. I said after you build the required parts, you assemble and mate them. Go to the Office Products tab, select SolidWorks Simulation. You get a new tab. Once you do that, you want to do a new study. It's a thermal study. Now we're ready to, you can name it if you want. And the first thing we want to do is change this so it's not a steady state analysis. We want a transient analysis. Of course, you can do a steady state analysis. It's much easier than a transient. But let's get in here and see if we can prescribe the kind of study you want to do. On study 2, properties, transient. Now, time increments and how long you want to go. Right, you can have this thing blow up on you if you make too big of a time step. Now, SolidWorks is going to have smaller elements, perhaps. You don't know the element size. Bottom line is it should change either your time step or your element size such that it won't blow up, right? That it's a stable solution. I don't know if it uses the implicit or explicit method here. It's probably using implicit, which is inherently stated. If you want it to run for a second, that's great. A tenth of a second, that means it's going to do 10 time steps. I don't know all this stuff. You can look into it. Solver, automatic, I don't know. You can do all this kind of stuff you want to, etc. Time to apply thermal loads. I won't show you them all, but it's very simple to do the thermal load on here. But one more thing before we do this. I think we want to make sure that everything's nice and sandwiched together. I believe I mentioned it in my PowerPoint here. Just get back to it. Properties, change transient. We got that far. The last thing here is you apply your thermal loads and you do this component context. You want to make sure everything's bonded. What does that mean? Well, it wants to know, you want to put contact resistances in between here? Well, we could. I just don't know anything about the way those materials are fused together, right? So I don't really know how to handle the contact resistances. You could estimate them if you wanted to. But we didn't do that with MATLAB, right? So we wanted to have this perfect bond that occurs here. You do that by going to your component contacts and making sure everything's bonded. Okay, thermal loads. I do it from up here. Let's say, for example, that you want to specify this thing starts out at 300 Kelvin. That's like a really important condition to have, otherwise it's going to assume it's at 0. So we have an initial temperature. By the way, that will not show up or allow you to click it if you didn't make it a transient analysis. Right? That should make some sense, that there wouldn't be an initial temperature requirement unless it were transient. And you can specify in here, for example, I want you to be 300 Kelvin everywhere. And a little check mark says, okay, boom. Oops. This is my entity. There. Now we can do that. That's an example of a way you apply a thermal load. Now, what are our other thermal loads? Without taking the time to go through them, what else do I want to apply on this? Corner symmetry.
Convection.
What about the very top? Insulated at the top, right? How about far away from the laser on the side? Over here. That whole side, not just that one edge, but 3 edges, right? 2. There's a depth here we're talking about now. How about that side? What do we say about that? Also insulated, yes. How about convection across the whole front face? Which that's the first part of this design project, is you got to calculate the combination of free and forced convection. External flow. Chapter, Adam? It is. You got it right.
You're good.
Free and forced convection combined, right? There's Nusselt to the end plus equals Nusselt of force to the end plus Nusselt of free to the end, right? You combine it that way. That's what the first part of the design project is. It's just flow over a flat plate. Wind's coming from one direction, I think, from the left, I think, on this. Okay, anyway, so you got some of your boundary conditions. Any questions, sort of how you set this up? After you run a study, well, you have to create a mesh. You get slider bar, that's all you get. You don't get to see the mesh size. It's just finer, takes a little longer. Coarser, a little easier. You might start off with a coarse mesh, so it goes very quickly for a short period of time, but you're going to have to run this thing for like a minute, right? Until you start doing things like changing your heat flux. At any rate, you do all this after you have all the boundary conditions in, you hit run, and then you'll get a set of results. And the results up here, it's reasonably intuitive, but you'll be able to do, for example, a probe plot. You can put your cursor right here and say, plot this as a function of time. Well, that's one of the graphs you have to produce. So it's an easy point to find. You can do a time history plot with 2 clicks or less, I think about 2 clicks, where you can literally get an XY plot that shows the temperature at this point as a function of time, which is one of your deliverables. I think you got 4 of those points you want, and then of course it'll automatically generate the contour plot for you. That's the first thing that'll pop up. A very pretty contour plot. Here's my point. This is like, okay, I could probably do the whole design project now in less than an hour, but it's certainly probably an order of magnitude for most of us simpler to kind of use this SolidWorks thermal analysis than it was to build that 2-dimensional MATLAB from scratch code. And hopefully what I've done here is kind of jump start you into the SolidWorks mode. For some of you, you're probably going to do this even faster than I could do it. Others who haven't seen it a longer time, hopefully this helped. Okay,